Most of the water on our planet is water that we can't drink or use to irrigate crops. And when I say most, I mean almost all of it. If the water on Earth was represented by 5 of these 5-gallon containers, then the water that we can use would be just half a teaspoon. If you live somewhere wet like Hilo, Hawaii, you might be surprised by this fact. How could so much of our water be unusable? The main answer is that the oceans are salty, and they are big, really big. How did they get to be salty, and why does Earth have so much water to begin with? I'm Science Mom.
I'm Math Dad.
Today we're going to explore where Earth's water is. That splash totally surprised me. Welcome. Hello to Catherine and Joshua and baby brother from Texas, to Tyler watching in Spokane, to Mindful Mission, Aubrey and Lucy from Minnesota. We are excited to talk about water today, and to start with...
It's a whole new topic.
It is a whole new topic. We're going into hydrology, and to start with, we have a fun little experiment.
Ooh, I like experiments.
So I have 4 jars right here. Math Dad has not seen what is in these jars, and we are not going to tell him. We are going to have him do a taste test and see if he can tell what is in these jars based on the water that I pour through.
They're empty, Jen.
So
Science Mom.
I have a filter here, and inside the filter is something,
Oh.
but I'm not going to tell you what. We're going to pour water through, and then I'm going to give you 4 little cups to taste from, and you're going to have to see if you can guess what was in the cups.
I think you're going to make a mess.
Don't worry, I have a towel.
You can't just pour water on top of a filter. Oh, this is a bad idea, guys.
So why don't you go grab Science Puppy, and I'm going to tell our unbeatable science kids what we have inside these containers. And then I would love to hear from you if you're watching live in the chat. Let me know if you think Math Dad will be able to taste this. This is not hot water that I'm pouring in. It's just regular water. So our very first cup right here has sugar cubes. And I'm going to add just a little bit of water and then let it percolate through. So sugar cubes is number 1. Number 2 is salted peanuts. So we're going to pour in some water into our salted peanuts container. Number 3 is shredded carrot. And then we have, last but not least, number 4, which is absolutely nothing. It is empty. And I'm curious for your predictions. Which ones do you think Math Dad will be able to taste? Which ones do you think he won't? You can already see our shredded carrots. The water's a different color. And now I'm going to carefully remove these containers. Here's where I am going to make just a little bit of a mess, but don't worry, I'll clean up when I'm done. So I'm going to put a little pile of my filtered stuff over here, and then we're going to pour them into 4 little cups, and we're going to see if he can taste them. And I bet I don't know if he'll guess correctly, but I bet he'll be able to taste a big difference in each of them, because water is an amazingly good molecule at leaching things out. So you know the word leach is like those blood-sucking animals that you find in freshwater ponds. Well, water can be a leach too. It can leach out minerals and salts from other things. So hopefully you remember what was in each cup, because now it's time for the taste test. We're not going to tell...
Back?
Yes, you can come back, Math Dad. We're not going to tell him what was in these. And we're going to see if he can identify them correctly.
All right, Callan's here to help me out.
All right. You ready for this?
All right, I'm ready.
Okay, first one right here.
All right.
Calvin gave it a sniff. Oh, let's change the view, though, so that you're bigger and they can see you.
Okay. Here goes. Kind of sugary.
It was sugar cubes.
Yeah, okay.
All right, next one. What do you think was in this cup?
All right.
And it's okay. You can say what it is in the chat, because Math Dad has his eyes closed. But thank you, Amaya.
Is it peanuts?
It is peanuts. Salted peanuts. So you could actually taste the peanut flavor.
Just a hint of it, yeah.
All right, keep those eyes closed.
All right.
Here's the next one.
Is he drinking from this?
No, Kaladin didn't drink from it.
What?
You can open your eyes and look at the water if you want.
It's got to be carrots, right?
It is carrots. And the water's, the water's orange.
Yeah.
The water's totally orange. So Math Dad, you're 3 for 3 so far. You've done really well.
All right.
Will you get the last cup? What is in the last cup?
I've got nothing.
Absolutely nothing.
Nothing. Well, okay. Then, yeah, it tastes like regular water. Going to be well hydrated today.
Now, just like the water picked up little molecules by going over this food, and it even picked up some of the things that you taste when you taste peanuts. I was curious about the peanuts. I thought they might just taste salty, and all Math Dad would taste was the salt. No, but you could tell that there was a peanut flavor. Well, as water is running over rocks, it does the same thing, and it will pull certain ions or small little molecules out. And that we kind of call that leaching. So if you put a rock in water, or if you put a piece of iron in water, minerals and ions or little bits of metal can actually leach out into the water and get in the water. And we need to understand this to be able to understand a little bit about why the oceans are salty.
Oh, so is it pretty much the same effect as the water is over time just absorbing
similar
minerals and...
Yeah, we'll get to that in just a minute. But first, let's talk a little bit about where the water on Earth is. In that little introduction, you saw me hold up a big 5-gallon container and say that if we had about 100 liters of water, the water that we can use would only be a teaspoon, half a teaspoon. That's so small compared to all the water on Earth. So how does that work? Well, we're going to go to page 86 in the notes and find out. So if you've got your notes, you can open up, turn to page 86. Let's just find out where the water on Earth is.
All right.
So the first thing that you need to understand is that most of the water on Earth, oh, Math Dad, that's a pretty cool effect. But I'm going to draw on us. So I think we shouldn't be.
All right. I was having fun. I like being a ghost.
Most of the water on Earth is salty. 97.5% is salt water. And that's because our oceans are so big and so deep. They cover a good portion of our planet, about 70%.
Mind-bogglingly enormous.
Yes.
If you've ever just been on the coast and you look out at all that water, you're like, wow.
That's a lot of water. So out of the water that is fresh, if we just look at this part right here, 2.5%, and we break it down.
That's pretty much just water that's outside of the ocean.
Water that's outside of the oceans. And let's take a look at that and say, okay, where is this fresh water? Well, most of it is frozen.
Oh, ice.
68.7% is ice in Antarctica and the North Pole and on glaciers and snow. And then we have 30%, just over 30%, that's groundwater underground.
So water that we don't have access to, we don't see it, it's just somehow underground. Does it sink down to the mantle?
Not quite that deep, not quite down into the mantle. It's in like the surface rocks, but it's not available to us most of the time. This little tiny bit, 1.2% of that 2.5%, that's surface water. But now let's take a look at the surface water. And if we take a look at the surface water here, a lot of it is ground ice and permafrost. And you know, the soil moisture, you can't just go and like squeeze out water from dirt and drink that. That's not very effective.
Nope.
And then the water in the atmosphere, we can't just go and like pull that out of the atmosphere very well. Water in swamps is not super useful. So the water that we can actually drink and use, we end up with rivers and
lakes.
And then also it depends on where the groundwater is, but sometimes we can use a little bit of groundwater too from aquifers. So that's the water we can use. But compared to where all of Earth's water is, oh my goodness, that's not very much.
All right, you used a fancy word there, aquifer.
We'll learn more about aquifers next week when we talk about your grounded lesson, when we talk about groundwater.
All right,
we'll learn more about that then.
I'll be patient.
But most of the water is in the oceans. And now let's turn to our oceans and talk just a little bit about them, because the oceans are incredible. And we say oceans because we talk about the Pacific Ocean and the Atlantic Ocean, but really there's just one world ocean.
So they're all connected.
They are connected. You can take a boat and you can sail from the Atlantic to the Pacific, but the basins that they occupy are distinct enough that it helps to have different names for different parts of our ocean.
So when you say a basin, I'm just getting this picture of these enormous bathtubs that are kind of connected, but there's this cool system, but the hollow out, that's the ocean basin you're talking about. Okay.
And in fact, that's kind of a good way to think about it. It's like a giant bathtub, but they're connected with these shallower areas.
They're overflowing. Yeah, I like that.
So the Atlantic Ocean and the Pacific Ocean are our two biggest oceans, and the Pacific is the biggest by far. But usually when people talk about oceans, they'll break it into 5 and talk about the Indian Ocean over here, and the Arctic, and then the Southern Ocean, where the water is really, really cold compared to around the equator. And if we look at the Pacific Ocean, it really does occupy almost half of one side of our planet. And this helps us just appreciate just how big the oceans are. And also, a lot of this water is really deep. Now, there's more life on land than there is in the oceans, even though the oceans are bigger.
Ooh.
And this might seem kind of strange. You might be thinking, wait a second, I've seen pictures of coral reefs and there are fish swimming around everywhere. But
well, and the other thing though is that in the ocean you can live in multiple levels too. Whereas on land, you're pretty much on the surface. You can't go up and live a mile high. But in the ocean, in theory, you could live a mile deep.
You can, as long as there's light and food. And it turns out that the light only goes so far. And so if you're looking at the Pacific Ocean, which is huge and vast, right around where there's coast and you have coral reefs, there is light, there is land for things to grow on, and you have coral and seaweed, and that provides a habitat for a lot of different animals. But in the middle of the ocean, when you have some light, but the water's always moving and drifting and changing, that's actually not a very great place to live. There's not a lot of nutrients there. There's a little bit of plankton, but that plankton might move, and then next week there might be no plankton there. And down below the light, it really is like the biggest, darkest, wettest fridge of all. And the reason we put food into a fridge is so that things won't grow, right?
Right.
Algae and mold and things won't grow because it's cold and it's dark. And the ocean is kind of like a big fridge. A lot of it is, where there's not much that lives in the middle where it's all dark and open.
Pretty bad growing conditions.
Yes. So there actually is more life on land. Now let's take a look real quick back at the Atlantic and Pacific Oceans. We said that...
What do you want me to do?
Right here.
Oh.
We said that the oceans are salty. Well, how salty? Around 3%. But the amount of salt actually changes a little bit depending on where you are. This is a graph from NASA showing the salinity of the world's oceans.
What's salinity mean?
Salinity means how much salt there is in the water. And I said it's around 3%. But if you are in the Mediterranean, it's just a little bit higher. And if you're in right here by the intertropical convergence zone, remember when we talked about weather patterns, that's where we get so much rain. So much rain is falling all the time that the water is actually a little bit less salty, just a little bit. It's still close to 3%. And if you took a cup from the Mediterranean and a cup from the equator and gave someone both cups and said, do a taste test, they'd both say, ooh, way too salty, way too salty. To us, 3% is really uncomfortably way too salty.
Yes, it is. Ooh, Patrick asks, is rain salty?
Rain is not salty because rain has been distilled. When water evaporates, the salt stays behind. And this is why our oceans are salty, because when water evaporates, the salt stays behind. And then the rain clouds are made from tiny little droplets of rain. And when they come back down and fall, it's mostly fresh water.
So that's why we can drink the rainwater. And we might give minimal treatment, but...
Well, and it depends. If there was a huge volcano next to you and the rain cloud was part of volcanic ash, or if there was a big chemical plant and the rain cloud had a lot of pollution in it, then you wouldn't want to drink the rainwater because there can be things dissolved in it. But the cool thing, one interesting thing about the oceans, the Pacific Ocean right here is actually just a little tiny bit taller, just a few inches taller than the Atlantic Ocean.
The elevation's higher?
Just a tiny bit. And part of it, about 8 inches.
Oh, wow.
And part of it is just because the Pacific Ocean is so big. So when tides happen and when the moon pulls on the water, you get a little bit different behavior in the Pacific than you do in the Atlantic. The Atlantic is just a little bit saltier and a little bit lower.
I did not know that.
Interesting, right?
Yeah, that's super interesting.
Are you ready, Math Dad, for a fact or fiction quiz about the ocean?
All right.
So I haven't told you everything about the ocean, but I've told you several things. And now it's time to see if you can pass.
Oh boy. Okay, chat. You might want to help me out on this. But
So this is a very popular picture that I've seen several times popping up on the internet. Is this true? You'll see this picture and then it will say the Pacific and Atlantic meet, but they never mixed. They never mixed. This is the border between the Pacific and the Atlantic.
Okay,
Fact or fiction?
all right. Well, there's no way I believe that somehow these, even with different salinities, that they wouldn't mix at all. But do they even meet? Because, okay, so they've got North and South America between them. The only place they really could meet up at the top, the Arctic Ocean, though, and down bottom is at the Southern Ocean, down the Straits of Magellan. So I don't even think they meet.
Well, they do meet. Look at the map right here. If you on a boat, you just
Isn't that the Southern Ocean down there? I'm okay. I thought this might be a trick question.
Oh no, it's not a trick question.
Because yeah, way back on this. Oh no, you're right. The Southern Ocean is below that. Okay. All right, I stand corrected. But they wouldn't mix. I mean, I have no idea what this photo is. It's kind of cool, but I don't buy it.
So
I don't know. Everybody, I'm seeing a lot of people saying true.
There's definitely a mixed feedback in our chat.
I'm going for fiction though. I don't believe it.
Math Dad, you are correct. This is fiction. So what you're seeing in this picture, this is sediment-heavy waters from glaciers in the Gulf of Alaska. And there was a lot of runoff from several rivers that had sediment. And the sediment that is in this water makes that water appear lighter, but it is mixing. Even though you can see kind of a distinct line here between the glacier water and the ocean water, if you come back the next day to this exact same spot, it's going to look different. And if you come back a month later, it'll look different again. The water currents are always moving and always mixing. And down where the Pacific and the Atlantic meet, you don't see any difference in color because you don't have massive rivers with glacier water right down there at the straits.
All right.
You ready for your next one?
Oh, another one. Okay.
The ocean is salty because it is concentrated river water. So rivers contain very small amounts of salt, and then the water cycle evaporates water from the ocean, and that's why the oceans are salty.
Okay, that's really weird wording. Concentrated river water. I mean, so you take river water and over years and years and years, it's going to wash some stuff in, but then it's going to get evaporated and go up. So this word concentrated river water, boy, that makes no sense at all to me. So I'm gonna have to say fiction.
So this one's a little complicated. Yes and no. So do most rivers go and enter into the ocean? Yes, and they're dumping their water in there, and then does that water get concentrated because you have water evaporating? Well, sort of. But here, look at this. This is interesting. If we look at river water doesn't just contain water. Just like when I poured the water over the carrots, and then we ended up with some little bits of carrots here. You can see the water is orange. It's different now. River water has ions. And the ions come mostly from rocks, but also like plant material that the water's going over. And if we look at what those ions are, and an ion is just an element that has, one or two of the electrons has left, and now it's charged and it's really happy being in the water. If we look at the ions in river water, they are different than the ions in salt water. Let's take a look at this graph. So in river water, we have a lot of this carbonate ion, and we don't have very much chlorine. This is the chlorine one, and sodium. And sodium chloride, that's table salt. That's what we have the most of in seawater.
Okay, but over time, we do get more sodium and chlorine building up.
There's a cycle, and it's actually really quite stable. The oceans have not gotten saltier for the last 1.5 years. Oh. They've stayed about the same. And it's because you have all of these processes that put ions in. Rivers bring ions. All of the earth that is underneath the ocean is leaching out little bits of ions. Volcanic vents leach out ions, and then rain brings ions. And if that rain is mixed with an explosion from a volcano, then it's going to bring different types of ions in.
Gotcha.
But you also have ions going out. And it turns out that the carbonate ions and the calcium ions and the potassium ions, they go out faster than the chlorine.
Wait, how are they going out?
So animals like a coral reef, they use carbonate and calcium to build the coral reef.
Oh.
So think about a little tiny animal like a baby fish, And then when it gets bigger, it has a skeleton. Well, where did the calcium in its skeleton come from? Came from the water.
Uh-huh.
And so the ions in and the ions out, it turns out that sodium and chloride, those are the ions that are the hardest to get out. And so the ocean, over a long, long time, the ocean ended up being quite concentrated with sodium and chlorine.
Boy, that really helps you see the geologic age of the Earth. I mean, it would take a long time to get that salty.
It does. But good news for us, that ocean is pretty stable now. This cycle here is keeping all of the concentrations of the salts pretty much the same. All right, next fact or fiction.
Oh, yeah.
You can turn salt water into fresh water. Is this true or false?
Boy, I mean, I imagine there's some process.
First, maybe let's just talk real quick. If you were on a boat in the middle of the ocean, Math Dad, and you were thirsty, should you drink the seawater?
I know you should not, because it will actually make you even more dehydrated, right?
It will. It is so salty. And if you have ever been to the ocean and accidentally gotten a bit of salt water in your mouth and accidentally swallowed it, you know that your body just immediately is like, oh, no, not the salt water. It's way too salty for us, and you will get more dehydrated drinking salt water than you would not drinking anything. So salt water is something that we can't use. If you pour salt water on a plant, that plant is going to die. And if you drink salt water, then you would die. But fresh water we can use and is very important for us. Can we turn salt water into fresh water?
Okay, so my theory there is, like through evaporation. I mean, we've got some processes that we can get it out. And like we went out in the desert once and put up a tarp and dug a tunnel, a little hole in the ground, and we were able to use the dew in the morning to get water.
Yep, and Kian and Great White and so many others in our chat are saying true, absolutely true. You can do it.
If you boiling the water,
yes,
manually. Okay.
So distilling is what we call this. And there are lots of different ways it can happen. You can just dig a pit and let the water evaporate. This is one of the oldest ways to make salt water usable. There are solar stills, these cool little devices that you can buy like for emergency water use, where you just set it on the ocean, and then it takes, the thing is, it takes energy for this to happen. You have to have the energy of sunlight coming in here, heating the water so it will evaporate and then go down and collect. And then here, this is a desalination plant, a big, huge plant in Portugal that actually uses energy from solar and fossil fuels to take water from the ocean and convert it into drinking water. And the way that this works, it really is like the water cycle in miniature. You have water here, and then you're evaporating, then condensing and collecting it. Evaporation, condensation, precipitation, collect the water.
Yeah, we did this exact experiment in the desert, and it worked. Although our water also got kind of sandy because it's tricky to set up.
It is. If you want to do it like this with stones and plastic wrap, you want to make sure you have a pretty big hole because it's easy to get dirt in your water. Last one.
All right.
Fact or fiction? Mount Everest would be underwater in the deepest part of the ocean. That's how deep the oceans are. And just for a reminder, Mount Everest is really tall. 8,800 meters or 29,000 feet above sea level. That is incredibly tall.
Yeah, that's 5.5 miles. Like that's really tall. That's interesting because my guess is that the ocean bottom is about that deep in the deepest parts, right?
Denali says fact. Corinne Bowser says fact. Olivia says true.
It's so close. Yeah, I guess I'll go with the chat on this one, but I'm not confident myself.
This is true. The Mariana Trench is 10,900 meters deep. That's 36,000 feet deep. That means if Mount Everest could fit in the Mariana Trench, spoiler alert, it couldn't because the Mariana Trench is a lot narrower. Mount Everest is pretty wide. But if it could, it would be a couple kilometers underwater.
Whoa.
That's how buried underwater it would be. Amazing, right?
That is deep. That really does help you appreciate how big the ocean is, though, when the world's biggest mountain just sink.
Would just be underwater.
Underwater.
Yeah. There are more volcanoes in the ocean than there are actually on land, but we don't really see the eruptions or know about them because they happen so far underwater. It's sort of like in Finding Nemo, that cartoon movie where there's a huge explosion and then at the surface there's just a little bloop, just a little bubble. The oceans are so big.
Huh. Well, thank you for your help on that one, chat.
All right. Real quick question from the chat that I saw. What is HCO3 negative back from this chart? So I'm going to pull this up again real fast. This is a carbonate ion, and it happens from rocks, but also from CO2, carbon dioxide, reacting with water. So the carbonate ion is a really common ion in river water, and then also calcium. See how high calcium is here, and the sulfur. But down here, or sorry, silicon oxide. Down here, though, the calcium is not very high. All right, let's head back now. I have a Where in the World mystery, and then it is going to be time for our poll, and also we will take questions from the chat.
So I've seen some good ones here. So
there have been some great ones. So Math Dad, are you ready for this? This is going to be a national park. We're in our national park trivia section. This park is deadly hot with sand dunes and salt flats. That's why I picked it for this lesson, because we're talking about salt today. The lowest point is 85 meters below sea level, but it also has fossils from an ancient lake and mountains covered with winter snow.
All right. I'm positive I know this one. It has to be Death Valley.
You are correct. It is Death Valley. This is a park we've been to several times, and the lowest point in the United States, Water Basin. This is what it looks like if you walk out maybe a half hour or so onto the salt. This is all that white that you're seeing is salt. And the reason that it has that cool kind of formation is just because of how the water evaporates. And if you get a little ridge, then salt is going to collect on it, and then the ridge over time gets bigger and bigger.
So it's going to have salt for reasons similar to why the ocean has salt. I mean, the salt just stays there when the water evaporates.
Exactly. So water is coming down from the mountains, and then as it evaporates, the salt is left behind. And there are some kids for scale so that you can see those rings are pretty good size.
Yeah.
They're pretty big. And Death Valley does have a lot of mountains. So this lowest point is actually in between mountains that go up to almost 12,000, just over 12,000 feet above sea level. So these mountains are really tall, huge elevation difference.
It's taller than the highest mountains in many states.
It is. And cool fact, this peak right here, Telescope Peak, from this point, you can see both Mount Whitney, which is the highest mountain, excuse me, the highest mountain in the continental United States. And you can see Water Basin, which is the lowest point. Kind of a cool thing, right?
That is pretty cool.
All right. We will now do our polls. Go to itempool.com/sciencemom/live. And while Math Dad is pulling up the polls, we want to wish a super happy birthday to Eric, who has a birthday today. We hope you have a great birthday, Eric. And we also are going to answer some of the questions that have come in, because we had some great questions.
All right.
So good question from Corinne. From Amelia, if such a small amount of water on Earth is usable, how can we even have enough for everyone? This is a great question. So water shortages are definitely a concern, and they're going to become more of a concern over the next few years. But the real answer is just because Earth has so much water. So we have a really wet planet, which is great. We need this water to help regulate the temperature of our planet, and because water is so important to us to stay alive.
Yeah, we're pretty small compared to these huge bodies of water.
Oceans.
So fortunately, Earth has enough water that even though a small portion of it is usable for us, that small portion is enough to support us. All right, we've gone to itempool.com/sciencemom/live. It is time for our questions. First question. The salinity of the ocean is the same in each ocean basin. So we got the Arctic, the Atlantic Ocean, Pacific Ocean, Indian Ocean, Southern Ocean. Is this true or false?
And Xander had a great question about the ocean being salty. Salinity just means that the ocean is salty. That's what that word means. And if the ocean is so saline or so salty, then can we just take the salt out so then we can use all that water? The answer is yes, but it requires energy to take it out. So if we use solar energy, then that's pretty good, because we have solar energy kind of comes for free. But if we're using fossil fuels to take the salt out, then we're producing a lot of carbon dioxide, and that is not good. So
wait. Saline solution is what people put contact lenses in, or you make slime out of. That just means salty.
A saline solution does have salt in it.
Saline. Aha. I got you. I see where you're going with this. All right, let's see how we did. And they said false. that the salinity of the ocean is not going to be the same.
And that is correct. Good job, unbeatable science kids. The Atlantic Ocean is slightly saltier than the Pacific. And remember, the Amazon River, you might have heard about the Amazon River before in Brazil. It's so big that even if you're about a mile away from Brazil, the ocean water there, it almost tastes fresh because the river is so big and the river is putting so much fresh water into the ocean. So it all depends on how much rain is falling and how many rivers you have. The salinity can vary.
All right, nicely done. All right. Approximately what percent of Earth's total water content is fresh water?
Of the total amount of water on the entire planet, how much is not salty? That's what we mean by fresh, not salty.
0.5%, 2.5%, 20%, 50%.
And Quinn asked a great question about humidity machines. And growing up in Utah and having lived in Nevada too, I did not know until we went back to Pennsylvania what a humidity machine was. And so here we use humidifiers sometimes that put water into the air, but if you live somewhere really humid, they have dehumidifiers, machines that will take humidity out of the air and collect it in a little pan that then you have to empty out. And is that water fresh? Yes, it is. Should you drink it? It all depends on how clean your humidity machine is. I wouldn't recommend drinking it.
All right. And the answer is 2.5%. They got it right. Oh, did you even say this one? How did they know that?
We did. This one, and this one's in the notes.
Oh.
These unbeatable science kids, Math Dad, they're
the
pretty
notes.
smart.
Oh, who would have thought they would have looked in the notes? All right. Nicely done, guys. Most of Earth's fresh water is frozen, contained in lakes, or underground.
Ooh. So the water that's not salty, where is it at? Is most of it frozen? Is most of it in lakes? Is most of it groundwater?
Because we just said that it was 2.5% approximately of Earth's water is fresh water, but how does that break down?
Yeah.
Which one has the most? Frozen, contained in lakes, or underground?
And Amaya asked, how do you identify salt water? Well, and I mean, an easy way for us is just taste, right? Like we can taste salt, and it doesn't have to be very much salt in there for us to be able to taste it. But a laboratory can tell you exactly what ions in there. So water tests, like water purity tests, there are certain chemical reactions that will tell you exactly which ions, like how much is calcium, how much is sodium and chloride.
Does fresh water have ions?
Super small amounts. For it to be fresh water, there is a threshold, if we're going to call it fresh water, and I think it's less than 1,000 parts per million of ions. And then, of course, ocean water has way more than that.
Is that why we have hard water here, though? Is because we have lots of minerals and
yes.
things?
So the difference between hard water and soft water, it has to do with how many ions you have in your water.
All right. Most of Earth's fresh water is frozen.
That is correct. Nicely done.
Way to go. And yeah, I mean, there's a lot in snow and ice and glaciers, and although it's getting less and less as temperatures rise.
And there also is a lot in lakes and groundwater. We'll talk about those more next time.
Okay. At the Panama Canal, so the ocean on the Atlantic side is about 8 inches higher than the Pacific side. And of course, with tides, that changes. So this must be an average number, or this question wouldn't make sense. All right. Is that true or false?
Fun fact, we have been to the Panama Canal to see it, and it's a pretty amazing thing to see. They bring the boats in, and then there are these gates that close, and then pumps will fill up the water level so that it's the same as the one next to them. And then they take them into that one, and gates close again, and then pumps change the water level because they have to move the boats up to a lake that is about 26 feet above sea level, and then the boats go across the lake, and then they have to come back down. But when they come down, they're not coming down to the exact same level. One side is a little different than the other.
Yeah.
So let's find out.
Really quite an engineering feat to
It
build.
is.
All right. And they said this is true.
Ooh, this was a trick question. It is false because it's the Pacific side that is a little bit higher.
Oh, crap. I got it wrong too then.
Oh, Math Dad.
Wait,
did you mark?
The Pacific side was the higher side?
Yeah.
Oh, no. Okay. I don't even get credit for defeating them because I got it wrong too.
So the unbeatable science kids got it right. Math Dad got it wrong.
No.
Bonus dance.
They also said true.
Oh, they also said true.
More of them got it wrong than got it right. So,
but you marked it true.
I marked it true, and they marked it true, most of them. So, Science Mom and her trick questions. Oh.
All right, next one. So we'll call that one a tie then, since I stumped you both.
Sure. Let you write the questions.
Or I get to do the victory dance.
There we go. Yeah, we see those dance moves. All right. Question 5. Are there more species on land or in the ocean? Ooh.
More species on land or in the ocean? And HS Mine asks, why are lakes not salty, but the oceans are? It all depends on which lake. And we will talk about this more when we talk about lakes. We have a lesson on lakes next week. Some lakes are salty. It all depends on how much water is going in and how much water is going out.
What's the saltiest place you know of? Or like something like Great Salt Lake, is that as salty as the ocean?
The Dead Sea has the record for being the saltiest and is even more salty than the ocean. So it all depends on the salt lake. And we'll talk about that when we talk about lakes.
Ooh, I'm excited for that lesson.
All right. I think the votes are in far enough that we have a clear winner.
And they said there are more species on land, and that is correct.
That is
5 out of 5. Or no. Well, they did as well as I did. So I'm not sure how to score you guys on that one. The science mom wrote a trick question.
Trick question. There we go. There's my dance. All right. Super fast. There were 2 more questions I wanted to answer really, really quick. Kelly Cunningham asked, how did the Mariana Trench form, that deepest point in the Pacific Ocean? And it's from plate tectonics. Remember how we talked about oceanic plates?
I thought it was the Atlantic Ocean.
Mariana Trench, Pacific Ocean.
Oh.
Just off the coast. Well, a ways away off the coast. From
Japan.
No,
it's got the mid-Atlantic ridge. That's what I'm thinking. It's the opposite of a trench.
Yes.
Okay.
So we have a subduction zone, and it is the deepest subduction zone right there in the trench. And real quick, why does salt make you thirsty? From Patrick. This is a great question. And there are really good questions, more than we have time to answer. I will try and pick a couple extras that we will answer next on Wednesday's class. But why does salt make you thirsty? And it's because we have salt in us as well. But the balance of salt in our blood has to be just right. And if it gets to be too much or too little, then our bodies are not happy. And so if you put extra salt in, then your body's like, ooh, we need water. And if you were drinking just plain water, especially if you're like working outside and it's really, really hot, if you're drinking just water and you're not eating anything salty at all, eventually you will start to feel pretty sick and you'll be craving something salty. True fact, we live right next to Hoover Dam in Nevada. And when Hoover Dam was being built, the summer here, the weather is really, really hot. So you had temperatures of above 110 degrees Fahrenheit. And you had these workers building the dam working outside. And they had several people die from dehydration and like heat exhaustion. And they started giving them salt tablets with their water. So you would have a salt tablet that you would eat every day. And then people didn't die from the heat after that.
So is this why sports drinks advertise lots of electrolytes? Is it the same type of thing? So it's actually better for you sometimes than just water? It all depends on how much you're sweating. If you are sweating a lot, then you are losing water through sweat. And if you're only drinking water because your sweat tastes salty, and you can do this as an experiment. Do a lot of exercise, get really salty, and then lick around your lips, and it tastes salty. If you exercise a lot and sweat, your sweat tastes salty. I've seen that before, yeah. Yeah. And so that's why sports drinks will say they have electrolytes, because that balance of salt inside us needs to be just right. And just like the ocean has all these systems to sort of keep the balance where you have ions in and ions out, your body does too. It's kind of an amazing thing. Yeah. Really good questions, guys. And we will work on filming some more Math Dad dances. We don't have any, but I see a great suggestion for a square dance and the Renegade and all sorts of good ones. Math Dad, we'll get to work on that. Work hard, grow smart, and we will see you on Wednesday. Bye, guys.